Today's lesson is 9.6. So here they want us to find sine of A. So we're going to circle A. We're going to label O, A, and H. We know for sine we use O and H. So the sine of A would be 1 over 2, or 1/2. If you recall from a lesson we did before this, we found the sine of a specific angle did in fact equal 1/2, or 0.5, and that angle was 30 degrees. So what that tells me is I can reverse engineer, if I know what the fraction or the decimal is of the sides, I should be able to work backwards and find out how many degrees the angle was. So we're going to use it the inverse when we're looking for the angle. If I know what the sides are, but I don't know the angle, then I'm going to use the inverse. So if I had angle A and I knew this was my O and my H, the sine of angle A would have been 4 over 7. So then angle A is really the inverse sine of 4 over 7. So the little -1 looking exponent is the inverse of the original trig function. So if the tangent of A is 3/4, then A is the inverse tangent of 3/4. And our calculator has the buttons for this as well. If you notice on the tangent button, it's probably very tiny on my screen, but if you have a calculator in front of you, usually on the tangent button, on the same button itself or above that button will be the inverse. So this is in blue, so I'm going to hit second and then the tangent button, and now I have that tan -1, and I already forgot my numbers. It was 3 over 4, so 3 divided by 4, we get 36.87 degrees. So the measure of angle A was 36.87 degrees. So then if I'm doing the same idea for B, B would be equal to the inverse sine of 0.87. So the second sine to get inverse, why do I forget the second I get away? 0.87, 0.87, and I get 60.46. So this is some for you to try. Pause if you'd like. The answers are posted online. For example 3, we want to find the measures of the acute angles. It doesn't matter which acute angle I start with. Let's say we want to start with angle A. So 25 is the hypotenuse, 24 is opposite, 7 is adjacent. Sometimes you're only going to know 2 of the sides to do this. We do happen to know all 3, so we're going to not use one side. It doesn't matter what one side we don't use, so let's pretend we didn't have this one here, and let's just use the O and the H. So if A was really equal, if the sine of A was really equal to 24 over 25, then A is equal to the inverse sine of 24 over 25. And if I use my calculator, I'm not going to show you these anymore because I'm sure you could figure out what buttons I'm pushing. The measure of angle A is 73.74 degrees. If I wanted to find C, I have 2 choices. I can get rid of my markings, relabel angle C with my O, A, and H. Let's pretend that I didn't have that 7 again, and now I'm using the A and the H. So C would be cosine of C would have been 24 over 25. So C is equal to the inverse cosine of 24 over 25. And I get 16.26. But there's one shorter way we could have done this. As long as I have not used a side that was not given to me, as long as I only use sides that were given to me, once I find the one acute angle, I could do 90 minus that angle to get the other one. And that's the only time I'm okay with you using an answer you already found to get another answer. All right, so we could use the angle we already found to find the other one. For try 3, all you're looking for is the measure of angle A. I would recommend not using this side because why would you want to use something that had a radical in it? Pause if you'd like. Answers are posted online. So we're going to have a lot of problems where the directions just say solve the right triangle. And what that means is you're going to find anything you didn't know about it before. There are two scenarios where you could solve a right triangle. One where you're given two side lengths. So you're going to have to find the third side and both of the acute angles. The other scenario is where you're given one side length and one acute angle. So that means you're going to have to find the other acute angle and both missing side lengths. So if we're given two sides, we're going to use the Pythagorean theorem to find the third side. We're going to circle one of the acute angles, doesn't matter which one, and label the given sides as O, A, or H. We're not going to label the side we just found, only the ones that were given to us. We're going to do inverse trig to find that angle, and then do 90 minus it to find the remaining angle. If I was given a side and an angle, I would start by doing 90 minus the angle to find the other one. I'm going to circle the angle that was given to me and label my sides with O, A, and H, and then solve for both missing sides using our regular trig. So for example 4, this is a scenario where I'm given two sides. So we're going to do Pythagorean theorem to find the third side. This is my C. So it's going to be 32 squared equals x squared plus 27 squared. So 32 squared is 1024. 27 squared is 729. 1024 minus 729 is 295. And when I take the square root, I get ST. I'm not going to write X because in the picture it was ST equals 17.18. All right, and now I'm going to work on solving for the angles. It doesn't matter which angle I choose. Let's say I chose R. 32 is the hypotenuse. This would have been opposite. This is adjacent. So using A and H, I know that R will be the inverse cosine of A over H, 27 over 32. So inverse cosine of 27 over 32. The measure of angle R is 32.46 degrees. And if I do 90 minus 32.46, that would give me the measure of angle T is 57.54. If you want to check to make sure that that is correct, if I had used cosine for R, I would use sine for T, so inverse sine of 27 over 32 on my calculator does in fact give me 57.54 degrees. So here's one for you to try. Pause if you'd like. Answers are posted online. All right, so here's one where we're given a side and an angle. I could find the other angle by doing 90 minus 25. We get 65 degrees, so the measure of angle G is 65 degrees. I was given this angle here, so I'm going to label H, O, and A from that angle. Even though I found G, I'm still going to use the one they gave me. And I'm going to cover up one of my sides at a time. So let's cover up the A side for now. So using O and H, that would be sine of 25 equals O, which is JG, over 13. So my variable's on top, which means I'm going to multiply. This is really going to be 13 times the sine of 25. And I get JG equals 5.49. So now I want to find the other missing side. So again, I'm not going to use the one I just found. I now have A and H, so we're going to use cosine of 25 equals A, which is HJ over 13. Again, we have the number on the bottom, so we're going to do cosine 25 times 13. And I get 11.78, so HJ equals 11.78. So here is one for you to try. Answers are posted online, but that is it for section 9.6.